Dear students, welcome you all to class 11 chemistry chapter 1 basic concepts of chemistry part 5. Topic is reactions in solutions. In lab, most of the chemical reactions are carried out in liquid form, and these liquid forms are called solutions. Solution is a homogeneous mixture consisting of two or more substances dissolved in liquid form. Homogeneous means that the atoms of the solute are dissolved or mixed uniformly in the solvent. Solution is a homogeneous mixture consisting of two or more substances dissolved in liquid form. Homogeneous mixture means atoms of solute are uniformly distributed in a solvent. Hope you understand homogeneous. Take for example sugar solution. Sugar is dissolved in water. The particles of sugar are dissolved such that they spread uniformly in the solution of water. Means if you taste the solution from any part, you will feel the same taste. That is called homogeneous mixture. Solution consists of two parts, a solute and a solvent. The substance which is dissolved in the solvent is called the solute, and the substance which dissolves the solute is called the solvent. Another method of explaining solute and solvent is on the basis of number of moles. In a solution, the substance which has less number of moles is called solute, and the substance in the solution which has more number of moles, that is called a solvent. Solution consists of solute and solvent. Substance which is dissolved is thus called solvent, or substance having less number of moles in a solution is called a solute. Solvent, substance which dissolves solute is called a solvent, e.g. water, acetone, ethanol, turpentine. These are examples of some solvents which dissolve solute particles. Or substance having more number of moles in a solution is said to be a solvent. Let us understand with an example. Question is, find solute and solvent in a mixture of 98 grams of sulfuric acid and 54 grams of water. To find solute and solvent, we have to first find the number of moles. Number of moles formula we know, given mass upon molar mass. For H2SO4, molar mass will be 98 grams in the given mass, and molar mass of sulfuric acid is 98 grams per mole. Therefore, answer will be 1 mole of sulfuric acid. If we take the case of water, water is given how much? 54 grams, and its molar mass is 18 grams per mole. And the answer will be 3 moles. Water clearly has more number of moles. Therefore, more moles means it will be a solvent. H2SO4 has less number of moles, so it will be a solute. In labs, before carrying out the chemical reactions, solutions are prepared of the reactants. These solutions are prepared by two methods. One method is that the solute is a solid thing, and that solid is dissolved in a solvent in which it is easily soluble. And other method is by diluting the stock solutions. Let me write first. Solutions are prepared by dissolving a given solid solute in a solvent in which solute is easily soluble, or by diluting stock solutions. What are stock solutions? Stock solutions are concentrated solutions which are diluted by adding more of the solvent. such that we get a desired concentration of solution which will help to carry out the chemical reaction easily. So concentration is most important term while carrying out chemical reactions in solutions. Let us understand what is a concentration and how is it calculated. Concentration of a solution is a measure of amount of solute present in a certain amount of solution or solvent. Concentration of a solution is represented in different ways. For commercial products, concentration is expressed in ratios of mass to mass or mass to volume. And these ratios are expressed in percentages. Means you have to first find the ratio and multiply it by 100 to convert it into percentage. Let me write. In commercial products, concentration is determined on basis of mass to mass ratios expressed in percentage or mass to volume ratios expressed in percentage. Mass to mass means mass of solute upon mass of solution. Mass to volume means mass of solute upon volume of solution. In commercial products, the terms used for expressing concentration are weight by weight percentage, volume by volume percentage, or weight by volume percentage. These are the three expressions which you will generally find written on the commercial products that you purchase from the market. Let me explain. The commercial terms of concentration are weight by weight percent, which is denoted by W upon W, volume by volume percent, which is denoted by V upon V, and weight by volume percent is denoted by W upon V percent. In case of very dilute solutions, two other terms are used in commercial products. They are parts per million and parts per billion. For very dilute solutions, the commercial terms of concentration are parts per million denoted by ppm and parts per billion denoted by ppb. Parts per million can also be expressed in terms of milligrams, and parts per billion can also be expressed in micrograms. For example, if I say 32 parts per million, I can also express this term as 32 milligrams of solute in 1 liter of solution. Similarly, if I write 32 ppb, that is part per billion, I can also say 32 micrograms of solute in 1 liter of solution. Let's now understand each of the commercial terms of concentration one by one. Weight by weight percent is also called mass percent. Mathematically, weight by weight percent is equal to mass of solute upon mass of solution into 100. For example, I write 10% W by W of NaCl solution. It would mean 10 grams of NaCl in 100 grams of solution. Another question, 10 grams of sugar dissolved in 100 gram of water. Find weight by weight percentage. We know formula of weight by weight percentage is equal to mass of solute upon mass of solution into 100. Here mass of solute is 10 grams. Mass of solution will be 10 grams of solute and 100 grams of solvent, that is water. So solution will be 100 plus 10 and multiply by 100. On solving, answer will be 9.09%. Let's take one more numerical. Question says 10 grams of NaOH dissolved in 100 ml solution. Find weight by weight percent if density of solution is 1.25 gram per ml. We have to find weight by weight percent, and the formula is mass of solute upon mass of solution into 100. Here we are given mass of solute and volume of solution is given. We don't know the mass of solution. So first we have to find mass of the solution. We are given density of solution, and that is equal to 1.25 grams per ml. Density is mass upon volume, and that will be equal to 1.25. Mass of solution we want to calculate, and V is given how much? 100 ml. So it will be m upon 100 equal to 1.25, and mass of solution will come out to be 125 grams. Now weight upon weight percent will be mass of solute, that is 10 grams, mass of solution, that is 125 grams, and multiply by 100, and answer will be 8% W by W solution. Next is volume by volume percentage. Volume by volume percentage is equal to volume of solute upon volume of solution into 100. For example, 10% V by V solution of hydrochloric acid aqueous, HCl aqueous. What is an aqueous solution? Aqueous solution is a solution in which the solvent is water. Aqueous solution is a solution in which solvent is water. 10% V by V solution of HCl aqueous will mean 10 ml of hydrochloric acid present in 100 ml of solution. Next term is weight by volume percentage. Third term is weight by volume percentage. It is equal to mass of solute upon volume of solution into 100. For example, a sugar solution of 5%, weight by volume is given. It would mean 5 grams of sugar in 100 ml of solution. Sugar solution of 5%, weight by volume would mean 5 grams of sugar in 100 ml of solution. Let us try some numericals on these commercial terms of concentration. Question says sugar solution is 10% weight by volume. Find its weight by weight percentage. Density of solution given is 1.25 grams per milliliter. We are given 10% weight by volume of sugar solution. It would mean 10 grams of sugar present in 100 ml of solution. Density of solution has been given, and that is equal to 1.25. Density is mass of solution upon volume of solution, that will be equal to 1.25. Means mass of solution will be equal to 1.25 into volume of solution. Now volume of solution we know 100 ml of solution. Therefore, mass of solution will be 1.25 multiplied by 100, and it will be 125 grams. We have to find weight upon weight percentage. Now weight of weight percentage is equal to mass of solute upon mass of solution into 100. Mass of solute is 10 grams. Mass of solution we have calculated 125 and multiplied by 100. When we solve it, answer will be 8%. Let's try one more numerical. Here question is reversed. Now we are given 10% of sugar solution weight by weight, and we have to find out weight by volume percentage of solution if density is 1.25 grams per ml. 10% weight by weight solution means 10 grams of sugar in 100 grams of solution. It means there is 10 grams of solute and 100 grams of solution. Density of solution is also given, and that is equal to 1.25. Density means mass upon volume of solution is equal to 1.25. Mass of solution we already know, it is 100 grams, and volume we can calculate by cross multiplying. So volume will be equal to 100 upon 1.25, and that will become 100 2 zeros and upon 125. That will be the volume of solution. We have to find weight upon volume percentage. Weight of volume percentage means we have to find out mass of solute upon volume of solution into 100. Putting the values, mass of solute is 10. Volume of solution we have just calculated 10,000 upon 125 and multiply by 100. Solving, answer will be 12.5% weight by volume of solution. Concentration on commercial level is expressed by these three terms. In lab, concentration is expressed by other terms, and these terms are molarity, molality, normality and mole fraction. We will be studying about them in detail. In labs, we do not use the commercial terms of concentration of solutions. In labs, we require solutions of particular volume with specific amounts of solute. For example, I want 1 liter solution having 42 grams of sucrose. To prepare this solution, I cannot simply add 42 grams of sucrose to 1 liter of water, because if I will add sucrose, the volume of water will increase. To get a particular volume of solution having a specific amount of solute, we have to take into consideration number of moles of solute present in the solution. Why number of moles? The basic fundamental principle is that the concentration of a solution may change, but the number of moles of solute will always remain the same. For example, if we take 1 liter of water and we are suppose having 3 moles of sucrose in it, we add more and more of water. Water is a solvent. When more and more water is being added, number of moles of solute will remain the same. However, concentration will change as we add more and more solvent. Let me write it. To prepare a particular volume of solution having specific amount of solute, number of moles of solute are determined. The principle behind is the number of moles of solute remains same. However, concentration of solution may change on adding more of the solvent. Based on the number of moles of solute, the concentration terms used in lab are molarity, molality and mole fraction. There is another very important term that is called normality. Concentration terms are molarity, molality, mole fraction, normality. Molarity is denoted by a capital M and it is calculated taking into consideration the volume of solution. Since the solutions can be prepared easily in liquid form, it is most widely used term. Molality is denoted by a small m. In labs, when scientists carry out experiments, they want that the volumes of solution do not change during the experiment. However, solutions being in liquid form, there may be change due to change in conditions of temperature and pressure. To get exact amounts of solute or solvent, the scientists use the term molality. Molality is calculated on the basis of mass of the solvent. Since mass of the solvent does not change with the change in condition of temperature and pressure, for experimental chemical reactions, molality is used by the scientist. So molality is calculated on the basis of the mass of the solvent, and this term is used in case of experimental reactions. Mole fraction is denoted by a small n, and mole fraction is simply the ratio of number of moles of any component in the solution to the total number of moles of all the components present in the solution. Mole fraction is ratio of number of moles of a component in solution to total number of moles of all components present in the solution. Next is normality. It is denoted by a capital N. Normality takes into account the reactivity capacity of molecules present in the solution. It is determined on the basis of gram equivalents. Now, what are gram equivalents? We will study in detail while we will be studying about normality in detail. However, normality is not very widely used. It is generally used during titrations or acid-base reactions. Titrations and acid-base reactions. Let us now understand each of these terms in detail one by one. Molarity is number of moles of solute in 1 liter of a solution. Mathematically, molarity is written as number of moles of solute upon volume of solution in liter. For example, if I say 1 m NaOH solution, what will it mean? It will mean 1 moles of NaOH in 1 liter of solution. From a solution of known molarity, we can prepare solutions of required molarity by diluting the solution. For example, I take a solution whose volume is V1 and it has suppose N1 number of moles of solute. And from this solution, I prepare another solution whose volume is V2 and number of moles here are N2. Number of moles of solute. Now molarity, say M1 for this will be as per the formula number of moles upon volume, and for here M2 will be equal to N2 upon V2. N1 will be equal to cross multiply M1 into V1, and this will be N2 is equal to M2 into V2. As we know, number of moles of solute will remain same even when the concentration of solution may change. Therefore, N1 should be equal to N2. If N1 is equal to N2, then M1 V1 will be equal to M2 V2. This is also known as dilution equation. We can also deduce a formula for calculating the molarity of a solution. which may be prepared by mixing two different solutions having different molarities. We are calculating molarity of mixture of solutions. Two solutions are given having volume V1, V2, molarity M1, M2 and number of moles of solute N1 and N2. Both those solutions are mixed and a new solution is prepared whose volume we can assume V, molarity M and number of moles equal to N. Going by the formula, N1 will be equal to M1 V1, N2 will be equal to M2 V2 and N will be equal to M into V. Now number of moles are in whole numbers. Therefore, N will be equal to sum of both N1 and N2. So I can write N is equal to N1 plus N2 or M1 V1 plus M2 V2. Putting the value of N in the last equation, I will be getting M1 V1 plus M2 V2 is equal to M into V. Now volume of mixture will be equal to sum of these volumes because this mixture has been formed by combining both these solutions. Therefore, I can write M1 V1 plus M2 V2 is equal to M into V1 plus V2 in place of V. Cross multiplying, I will be getting M is equal to M1 V1 plus M2 V2 upon V1 plus V2. Thus, we can determine molarity of mixture of solutions. Let us try some numericals on molarity. Question is, find molarity of 250 ml NaOH solution prepared by dissolving 4 grams NaOH in water. We have to find molarity M. And molarity formula we know, number of moles of solute upon volume of solution in liter. What we have been given? We are given mass of NaOH, that is 4 grams. We are also given volume of solution, that is 250 ml. Since here we have to take volume in liters, we may convert it into liters, 250 upon 1000 liters. Number of moles, we know the formula is given mass upon molar mass. Mass of NaOH given is 4 grams and molar mass of NaOH is 40 grams per mole. Therefore, number of moles will be 1 upon 10. Putting both these values in the formula, M will be equal to 1 upon 10 divided by 250 upon 1000. And solving, we will be getting 0.4 molarity as the answer. Question says, find mass of NaOH present in 100 ml of 3 molar NaOH solution. Let us first write what is given. Molarity is given 3. Volume of solution given 100 ml. Let us convert it into liters. 100 upon 1000. And it will be 1 by 10 liter. Now we will look at the formulas. M is having a formula N upon V, number of moles of solute upon volume in liters. We have to find mass of NaOH. So we have to look for another formula because we cannot calculate mass from here. Now we have the formula of number of moles equal to given mass upon molar mass of NaOH. Molar mass of NaOH is 40, so M upon 40. So mass of NaOH will be 40 into N. We have to find out N. N we can find from this formula. N is equal to M into V. Molarity is given 3. Volume is given 1 upon 10. So number of moles is 3 upon 10. Putting in this formula 40 into 3 upon 10 and the answer will be 12 grams. What is difference between 0.50 mole Na2CO3 and 0.50 molar Na2CO3? We are given 0.50 moles of Na2CO3 and we are also given molarity is equal to 0.50 of Na2CO3. 0.50 moles of Na2CO3 can be converted into mass. So mass will be equal to number of moles into molar mass of Na2CO3. Molar mass of Na2CO3 is 106 grams. So 0.50 into 106 grams, and it comes out to be 53 grams. Therefore, according to this statement, 0.50 moles of Na2CO3, it means we have got 53 grams of Na2CO3. Let us check what molarity is saying. Molarity formula we know, number of moles upon volume of solution. That is equal to 0.50. It would also mean 0.50 moles of Na2CO3 in 1 liter of solution. Moles can be converted into mass. Mass is already we have calculated 53 grams. So I can say 53 grams of Na2CO3 in 1 liter of solution. So difference between the two is that here we are just given 53 grams of Na2CO3. Here again we are given 53 grams, but those grams are dissolved in 1 liter of solution. Next. Question says density of methanol, that is CH3OH, is 0.793 kilograms per liter. Find volume of methanol needed to make 2.5 liters of its 0.25 molar solution. So we are given density of methanol is equal to 0.793 kilograms per liter. We are also given volume of the solution that we have to prepare, that is 2.5 liters. And we are given molarity is equal to 0.25. Density formula we know, mass per unit volume, and that is 0.793 kilogram per liter. I have to find the volume of this methanol which has been used to prepare this solution. That is, I have to find this V. For finding V, I have to first calculate mass of ethanol. Let us look at other formulas in the question. Molarity formula is number of moles upon volume of solution in liter, and that is equal to 0.525. I can calculate number of moles. Number of moles is equal to 0.25 into 2.5 liters, that is given, and on solving I get 0.625 moles. So there are 0.625 moles of methanol present in both the solutions, because number of moles of solute will remain the same in the solution. Now number of moles formula is given mass upon molar mass of methanol. Molar mass of methanol is 32 grams. So M upon 32. So mass of methanol will be N into 32, and I have already calculated 0.625 into 32. We now know mass of methanol, and that is 20 grams. Here density is given in kilograms, so let us convert it into kilogram. 20 upon 1000. That is 0.020 kilograms. Volume will be equal to mass upon 0.793, and mass is 0.020 upon 0.793. Solving we get 0.02522 liters of methanol. Question says 0.85 liters of 5 molar copper nitrate solution has been diluted to 1.80 liters by adding water. Find molarity of the diluted solution. Here we can use the dilution equation. Dilution equation is M1V1 is equal to M2V2. M1 we take 5, V1 is 0.850. M2 we have to calculate, and V2 given is 1.80. M2 will be equal to, it comes out to be 2.36. Next question is, if 0.2 molar 100 ml HCl solution mixed with 0.1 molar 300 ml HCl, find molarity of mixture. We know the formula of calculating molarity of mixture, and that is equal to M is equal to M1 V1 plus M2 V2 upon V1 plus V2. Putting the values, M1 0.2 we can take, and it is 100. M2 we can take 0.1 and it is 300, and V1 100 plus 300. Solving we get 20 plus 30 upon 400, that is 50 upon 400, and solving we get 0.125 molar solution of mixture. We have to find mass of potassium hydroxide in 150 cubic centimeter of semi-molar aqueous solution. Molar mass of potassium hydroxide has also been given 36 grams per mole. Here what is semi-molar? Solution on the basis of molarity has been given some names. If the molarity is 1, it is called a molar solution. If molarity is 1 by 2, it is called semi-molar. And if molarity is 2, it is called bimolar. Let me write. If molarity is 1, it is called molar solution. If it is 1 by 2, it is called semi-molar. If 2, it will be called bimolar. For 3, trimolar. If it is 1 by 10, it will be called decimolar solution. And if it is 1 upon 100, it is centimolar solution. Let's start with the question. Semi-molar means molarity is 1 by 2. M is equal to 1 by 2. We are also given volume is equal to 150 centimeter cube. 1 centimeter cube is equal to 1 ml, so it will be 150 ml. Convert into liters, it will be 150 upon 1000 liters. That is 0.15 liters. We have to find mass of potassium hydroxide. Now formula of molarity is number of moles upon volume is equal to 1 by 2. I can calculate moles 1 by 2 into V, and it comes out to be number of moles. Formula we know, given mass upon molar mass. So mass of potassium hydroxide will be equal to number of moles into its molar mass, and that is given 36 grams per mole. Number of moles we have calculated 0.75 and multiplied by 36. Answer will be about 2.7 grams. Question is, 98% sulfuric acid solution by mass has density 1.80 grams per milliliter. Find volume of acid required to make 1 liter of 0.1 molar sulfuric acid solution. We are given two solutions, that is 98% sulfuric acid solution, and we are to make a solution of molarity 0.1. Let me write the solutions given. We can use dilution equation to solve this numerical. Dilution equation is, here I can write M2V2 and here I may write M1V1. M2 I know 0.1, V2 I know 1 liter. Here I have to find out this V1. And M1 first I have to calculate. What are we given? We are given 98% sulfuric acid solution by mass. What does it mean? It means 98 grams of sulfuric acid in 100 grams of solution. Density formula we know, mass per unit volume. So M upon V will be equal to 1.80. We know the mass of solution 100 grams. We can find the volume of the solution. So volume of solution will be mass upon 1.80. Mass is 100 grams and it is upon 1.80. This is in ml. We can convert it into liters by dividing by 1000. And on solving, I will be getting 1 upon 18. liters of volume. Now we have to find molarity. Molarity formula we know, number of moles upon volume in liters. Number of moles of solute. Solute here is sulfuric acid. Sulfuric acid, number of moles, how can we calculate? Again the formula, given mass of the compound, we are given how much? 98 grams upon molar mass of compound. Molar mass of sulfuric acid is 98 gram per mole. So number of moles will be 1 mole. Putting the number of moles in this formula, I can calculate molarity. So 1 mole upon 1 upon 18 liter is the volume, and molarity comes out to be 18. Now I can use the dilution equation formula. According to the formula, M1V1 is equal to M2V2. Correct? M1 is 18. V1 we have to calculate. M2 0.1 and V2 is 1 liter, convert it into ml and it will be 1000 ml. Further solving, V1 will be equal to 0.1 into 1000 upon 18 and the answer will be 5.55 milliliters. We can also calculate the molarity of ions which are formed during a chemical reaction. Let us try a numerical on it. Question says, find molarity of hydrogen ions formed on dissolving 49 grams of sulfuric acid in 250 milliliters of solution. When sulfuric acid is dissolved in water, it dissociates into ion, hydrogen ions and sulfate ions. We have to find the molarity of hydrogen ions. What is given in the question? We are given two things, mass of sulfuric acid and volume of solution. And volume is given 250 ml. ml we can convert into liters by dividing by 1000. 250 by 1000 and the answer will be 1/4 liters. Since volume of solution is given, we can calculate molarity. Molarity formula is number of moles of solute upon volume of solution. Since mass of solute is given, that is sulfuric acid is given, we can calculate number of moles of sulfuric acid. And the formula is given mass upon molar mass. Molar mass of sulfuric acid is 98 grams per mole. So number of moles will come out to be 1/2 moles. Putting the values of N and V in molarity formula, the solution will be 2. It means there are 2 moles of sulfuric acid in 1 liter of solution. To find the molarity of hydrogen ions, we have to write the chemical equation of dissociation of sulfuric acid. And the equation is sulfuric acid H2SO4 dissociates into 2 hydrogen ions plus sulfate ions. Going by the equation, 1 mole per liter of sulfuric acid produce 2 moles per liter of hydrogen ions. We are having H2SO4 how much? 2 moles per liter. So 2 moles per liter of sulfuric acid will produce 4 moles per liter. Therefore, molarity of hydrogen ions comes out to be 4. Let's now understand molality. Molality is denoted by a small m. It is defined as number of moles of solute present in 1 kg of a solvent. Molality is number of moles of solute in 1 kg of solvent. Mathematically, M is equal to number of moles of solute upon mass of solvent in kilograms. Let us try a numerical on it. Question is, density of 3 molar solution of sodium chloride is 1.25 gram per milliliter. Find molality of the solution. We are given molarity, that is equal to 3. And we are also given density of the solution, that is 1.25 gram per milliliter. We have to find molality. Let me first write the formula of molality. Molality is number of moles of solute upon mass of solvent in kilograms. Molarity is equal to 3. That means there are 3 moles of sodium chloride in 1 liter of solution. Number of moles, I can say 3 moles per liter. Since we know the number of moles of sodium chloride in 1 liter of solution, we can calculate mass of sodium chloride present in 1 liter of solution. So mass of sodium chloride will be equal to number of moles into molar mass of sodium chloride. Number of moles are 3 and molar mass of sodium chloride is 58.5 grams per mole. And on multiplying we get 175.5 grams. We have calculated mass of solute present in the solution. We are also given density of the solution. Density formula we know, mass per unit volume. So m upon v will be equal to 1.25. Volume of solution we know is 1 liter. 1 liter we convert into milliliters. So m upon 1000 milliliter will be equal to 1.25. So m will be equal to 1.25 into 1000 and it will be 1250 grams. This is the mass of the solution. So we are having mass of the solution as well as mass of solute. So we can calculate the mass of solvent by subtracting them. So mass of solvent will be equal to 1074.5 grams is the mass of solvent. Now we can calculate the molality. Molality will be equal to number of moles is 3. Mass of solvent is 1074.5 grams. It is in grams, so we will convert into kilograms by multiplying by 1000 and the answer will be approximately 2.79. Next is the mole fraction. Mole fraction of a component in a given solution is defined as the number of moles of that component to the total number of moles of all the components present in the solution. So mole fraction of a component in a solution is the number of moles of that component to the total number of moles of all components present in a given solution. Suppose I have a solution which contains 2 substances, say A and B. Let us assume A component has number of moles, say Na, represented by Na. Similarly, B may have number of moles Nb. If I am to find the mole fraction of component A, that will be equal to number of moles of component A, that is Na, upon or divided by total number of moles of all the components present in the solution, that is Na plus Nb. Similarly, if I am to find the mole fraction of component B, it will be equal to Nb upon Na plus Nb. If we add up mole fractions of both the components, mole fraction of the solution will be equal to 1. Total mole fraction will be Na upon Na plus Nb plus Nb upon Na plus Nb, and by solving it I'll be getting 1 as the answer. Let's try a numerical on mole fraction. Question says find molarity of solution of ethanol in water if mole fraction of ethanol is 0.040 and density of water is 1 gram per milliliter. We have to find the molarity. Molarity formula we know. Molarity is equal to number of moles of solute upon volume of solution in liters. As per the question, the solution has two components, ethanol and water, where ethanol is the solute. So we have to find number of moles of solute, that is ethanol, to find the molarity of solution. Let us see what is given. We are given mole fraction of ethanol is equal to 0.040. Let us assume ethanol is component A and water is component B in the solution. As per the formula, mole fraction of ethanol will be equal to number of moles of A, that is ethanol, upon number of moles of A again, plus number of moles of B, that is number of moles of water. And that is given 0.040. We are also given the density of water, which is equal to 1 gram per ml. We can find mass of water in 1 liter of solution. We can use unitary method. 1 milliliter of water will have mass 1 grams as per the density. Then 1000 ml, that is 1 liter of water will have 1000 grams. Let me write. From mass of water, I can calculate number of moles of water. Number of moles formula is mass of the compound upon its molar mass. Given mass is 1000 grams and molar mass of water is 18 grams per mole. Number of moles of water, that is NB, will come out to be 55.55 moles. I'll put this in this formula. Solving this equation numerically, we will be able to calculate number of moles of A, that is the number of moles of ethanol, is equal to 2.1 moles. We have assumed here that the volume of solution is 1 liter. Therefore, molarity will be number of moles of ethanol are 2.1 and volume is 1 liter. So, molarity will be 2.1. Let us now try a few numericals on parts per million, which is also a term of concentration. Question says 8 into 10 to the power minus 4 grams of oxygen is dissolved in 100 grams of water. Find concentration of oxygen in solution in parts per million. Going by the definition of parts per million, we can convert it into grams. Parts per million is equal to number of micrograms present in 1 liter of solution. I can also say 10 to the power minus 3 grams in 1000 milliliter of solution. In the question we are given mass of oxygen is equal to 8 into 10 to the power minus 4 gram. We are also given mass of water, that is equal to 100 grams. We know density of water is 1 grams per milliliter. Therefore, 100 grams of water will be present in 100 milliliters of water. So 1 gram of water has volume 1 milliliter, then 100 grams of water will have volume 100 milliliters. Now 100 milliliters of water contains how much oxygen? 8 into 10 to the power minus 4 grams. Then 1000 ml of water will have oxygen equal to 8 into 10 to the power minus 3 grams, which will be further equal to 8 micrograms. Or we can say 8 parts per million. Let's try one more numerical. Question is, sea water has 53 parts per million of sodium carbonate. Find mass of sodium carbonate in 1 glass whose volume is 250 ml. We are given 53 parts per million. 53 parts per million means 53 3 micrograms of sodium carbonate in 1 liter of solution or 1000 milliliter of solution. Converting micrograms into grams, 53 into 10 to the power minus 3 grams of Na2CO3. Applying unitary method, 1000 milliliter of solution is having sodium carbonate is equal to 53 into 10 to the power minus 3 grams. Then 250 milliliter of solution has sodium carbonate equal to 53 into 10 to the power minus 3 upon 1000 multiplied by 250. On solving, answer comes out to be 1.325 into 10 to the power minus 2 grams. Here we come to the end of part 5 of class 11 chemistry, chapter 1, basic concepts of chemistry. In next part, we will be studying about normality. To understand normality, we have to first understand the concept of equivalence. This concept has not been prescribed in your book, but from competitive exams point of view, we must learn this topic. Till then, keep working hard and working hard. Thank you.